Hi, this video is regarding the link between the imaginary parts of the zero of zeta and the distribution of prime. As you know, the infinite product, the Eulerian infinite product, is a spiral going to a unique point when you are multiplying 1 with under 1 minus p puissance moins s at the infinite. You are going to 0, and it is a spiral. You can separate this spiral into two parts, the parts upside with the imaginary part positive and the other one with the imaginary part negative. And so you got two semi-spiral. The interesting point is that these spirals are diminishing rapidly, progressively, but in fact the population, the cardinal, inside each of the circle, the semicircles, is exponentially growing. So you can do the logarithm of the evolution of the population, and you've got a straight line with a coefficient, okay, for each zero of zeta. And in fact, when you are doing some data science with a lot of prime numbers, you can find a quite nice relation between the zero of zeta, imaginary part, r, the real part, and the coefficient of the straight lines of the exponential evolution, and so the straight line of the logarithm of the cardinals of all the semicircle. And in fact, you've got a direct relation between the zero of zeta, imaginary parts, and the coefficient of the straight lines, which is the following. P divided by 2, P 2 under, minus arctangent of 0 of zeta imaginary part puissance 1 under r equal directly a constant depending of r multiplied by the coefficient of the straight line à la puissance 1 sur r. I repeat, P divided by 2 minus arctangent of 0 zeta imaginary part à la puissance 1 sur r, fermé arctangente, is equal a constant depending of r, but a constant, multiplied by the coefficient of the straight line of the regression of the logarithm of the cardinals, a coefficient depending of r, of zeta, imaginary part, puissance 1 sur r. And this is okay for all the value of r, 0.5, but all the other value. So in fact, the interesting part of the repartition of the zero of the zeta function is not especially 0.5, but the repartition of the imaginary part of the zero of zeta, which is the most significant, which is directly linked to the repartition that the cardinal should have to satisfy the equation. Donc, I repeat for the last time the formula. P divided by 2 minus arctangent the imaginary part of 1, 0 of zeta à la puissance 1 sur r, fermez la parenthèse, equal a constant depending of r multiplied by the coefficient of the regression of the evolution of the cardinals of the semicircles à la puissance 1 sur r, with r equals 0.5, 0.5, or another value. That's great. That's a generalization of the Riemann hypothesis, in fact, and that's a clear focus on the distribution of the prime numbers. I think that the function the air, car of air, it's quite easy to simulate. I will do it. Bye bye.